Today, we're going to evaluate the indefinite integral of sine of the square root of x. First, we'll make a substitution to simplify the integral. Then, we'll apply integration by parts to solve it. Finally, we'll back substitute to the original variable and simplify the final answer. Let's get started. Here is our initial integral, the integral of sine of the square root of x dx. We'll start by letting u equal the square root of x. Then, we'll express dx in terms of do. If u equals the square root of x, then squaring both sides we have x equals u squared. Differentiating both sides with respect to x, we obtain dx equals 2u do. Substituting u for square root of x and dx for 2u do, our integral becomes the integral of sine of u times 2u do. Now it's time to apply integration by parts. Remember, integration by parts follows the formula. The integral of u dv equals uv minus the integral of v do. We'll choose 2u as our first u term and sine u do as our dv term. In this case, we'll let capital U be equal to 2u, so do will be 2 do. Next, let dv equal sine of u do, then integrating, v will be negative cosine of u. Since the integral of sine is negative cosine, so now we can apply our integration by parts formula, substituting back in for u, do v, and dv respectively, gives us 2u times negative cosine of u, minus the integral of negative cosine of u, times 2 do. And that simplifies to negative 2u cosine of u plus the integral of 2 cosine u do. Let's integrate this next integral to finish up our integration. The antiderivative of cosine is simply sine, so we integrate the cosine integral and rewrite that as part of our equation. This becomes negative 2u cosine of u plus 2 sine of u plus the constant of integration. Finally, we'll back substitute to express our solution in terms of the original variable x. Replace u with the square root of x. This yields negative 2 square root of x cosine of square root of x plus 2 sine of square root of x plus the constant of integration. And that's our final answer.